All right, welcome to the end of the workday video. It's 6:43, so let's get started. I've got some time to do a video here. So I just finished a new series on getting hired, but before that, I was. It's kind of funny. This was my most popular series, so I figure, hey, why not go back and look through this? And you know what? I'm kind of not. I'm kind of glad that I did that because the content of this last part of this chapter is actually pretty good. But if you look at my analytics, so if we click analytics here, and then we look at, uh, so if we go back to the channel content, and then we click on analytics, and then we click on the top content and sort it by the number of views, which is already more difficult than I'm would think would be. This is more difficult than I would like this, and I'm surprised people aren't complaining about how difficult this is. Okay, so yeah, so we have to sort this by lifetime. And yeah, so we can see over the course of my channel, big views, things are going really well. Now we can see the top video is the top 3 videos are from this book. So that's kind of, I think, that's what's like, hey, maybe I should keep reading this book. I'm almost done with it. Not all of it was garbage, just the stuff in the middle seemed pretty garbage. And it's about AI, which I want to be learning about anyways. So now this one got two. These got 2 minutes, but you can see if you click on it for the analytics, and you look at the yeah. So this is the retention for the video. So people are watching. So after a minute in, so after a minute and a half, 90% of the people who initially tuned into the video are no longer watching it. And what happens after a minute and a half? My goofiness is now no longer so prominent. So the reason this blew up is because I have this porn stash, and I let my hair grow out into a male baldness pattern, very prominent. I raise my eyebrows like that. I have my giant glasses on. That I really liked having bigger glasses because it increases my field of vision. And yeah, messy room, all of that. So yeah, maybe I'm doing this series, continuing it, not for the right reasons, just kind of these metrics really need to just be doing more of kind of. I need to be more firm in like what makes sense for me to do. I think what makes sense for me to learn is just a basic introduction to the AWS cert. I think getting that makes a lot of sense, and then SRE makes a lot more sense than anything else. So like reading some of the books on here, and there's you can read these for free online. So that's what makes sense. So that's the workbook. Yeah, so that's what makes sense. It's not what I'm doing. What I'm doing is kind of following the data, but if we look more closely into the data, we can see it's likely because people are just kind of noticing how goofy I look and how much my room is bare and trash, and for whatever reason, like you would slow down on the road to see a car crash. I got nearly 5,000 views. But anyways, this channel has never really been about views anyway. I appreciate the subscriptions. It does help keep me motivated. But the point of this channel is to develop hard technical skills for a career in tech. So that's what I'm going to continue doing. Okay, so if I hit the sync button here, there we go. Now I'm up to sync. So I'm 81% of the way through. So I'll double click this. There you go. Now that I double clicked it, I'm in. So, and then this is the only bookmark. So yeah, so we're starting chapter 15 in this video, which is on data engineering. Data science may be the sexiest job of the 21st century, but the field is evolving rapidly into different job titles. Data scientist has been too crude a description for a whole series of tasks. As of 2020, two jobs that can pay the same or more are data engineer and machine learning engineer. So these are the hot titles in 2020. I would say they're even hotter now in 2024, 4 years later. Even more surprising is the vast number of data engineer roles needed to support a traditional data scientist. So it's kind of, it looks like it's the data scientist is lateral. So like a data science will have data engineers working for them. The data scientists will do like the planning, and then the execution, implementation will be done by the engineers, it looks like. It is somewhere between 3 to 5 data engineers to 1 data scientist. So there you go. If you want to get into this field, I would recommend becoming a data engineer over a data scientist just based on that, because your odds of getting hired are better. If you want to be a data scientist, you might need like a PhD, like really the hard credentials. So I recommend going for the one you can get. What is happening? Let's look at it from another angle. Let's pretend we are writing headlines for a newspaper and want to say something eye-catching. We could say, CEO is the sexiest job title for the rich. There are few CEOs, just like there are few NBA stars, just like there are few professional actors who are making a living. For every CEO, how many people are working to make that CEO successful? This last statement is content-free and meaningless, like water is wet. Wait, which statement? For every CEO, how many people are working to make that CEO successful? Wait, which statement? So the last statement before this sentence was, for every CEO, how many people are working to make that CEO successful? And then it says this last statement. So I this statement maybe is content free and meaningless, like water is wet. Which I don't understand. I'm gonna read this whole thing again, and maybe some of the last, but I'll read this whole thing again because I don't understand that. So what is happening? Let's look at it from another angle. Let's pretend we are writing headlines for a newspaper and we want to say something eye-catching. We would say, CEO is the sexiest job for the rich. Okay, so is that the content-free and meaningless statement? There are few CEOs, just like there are few NBA stars, just like there are few professional actors who are making a living. For every CEO, how many people are working to make that CEO successful? This last statement is content-free and meaningless, like water is wet. Okay, well, I guess I'll just continue on to read. This statement, which statement? Okay, so I'm assuming the statement is, for every CEO, how many people are working to make that CEO successful? So that statement is content free and meaningless, like water is wet. I guess the point they might be trying to make is that it really is about the CEO. It's not, the CEO actually is a role that kind of depends on rugged individualism more than it does like the people working to make the CEO successful. I guess maybe that's the point they're making. So this statement isn't to say that you can't make a living as a data scientist. It is more a critique of the logistics behind the statement. Okay, this book is trash. This is why I stopped reading this book. This is absolutely garbage. I do not know what they're saying. I don't know which statement. This one, right? It is more a critique of the logistics behind the statement. There is a huge demand for skills in data, and they range from... this is making me mad, actually. This is making me not want to read this book anymore. There is a huge demand for skills in data, and they range from DevOps to machine learning to communication. The term data scientist is nebulous. Is it a job or a behavior? In a way, it is a lot like the word DevOps. Is DevOps a job or is it a behavior? In looking at job posting data and salary data, it appears the job market is saying there is an apparent demand for actual roles in data engineering and machine learning engineering. This is because those roles perform identifiable tasks. A data engineer task could be creating a pipeline in the cloud that collects both batch and streaming data and then creates APIs to access that data and schedule those jobs. This job is not a squishy task. It works or it doesn't. Likewise, a machine learning engineer builds machine learning models and deploys them in a way that they are maintainable. This job is also not squishy. An engineer can do data engineering or machine learning engineering, though, and still exhibit behaviors attributed to data science and DevOps. Today is an exciting time to be involved in data, as there are some considerable opportunities to build complex and robust data pipelines that feed into other complex and powerful prediction systems. There is an expression that says you can never be too rich or too thin. Likewise, with data, you can never have too much DevOps or data science skills. Let's dive into some DevOps flavored ideas for data engineering. All right, so I guess I'm no longer like angry because I think I understand the point, and I think they made a coherent point. And I think the point was that oftentimes these labels are not useful, and they don't actually tell you the skills behind them or the tasks behind them. So you shouldn't get so much hung up on, do I want to be a data engineer, a data scientist, or work in DevOps? And instead you should learn the skills and master as many skills as you can. So I think yeah, so I think that's the point they were making there. I did not understand it. Perhaps it just wasn't written in a way that I would understand, but the average person that would really click with. But for me, I thought that was actually really bad writing, because it wasn't clear which statement. Because they made a number of statements. They put one statement in quotes. They made a statement after that, and then they made a third statement, and then they said this last statement is meaningless. Which, I mean, that seems like a very meaningful statement. CEOs typically do have, the board of directors, the CTO, like a secretary. So I don't understand why that would be meaningless, and it doesn't go on to explain why that would be meaningless if assuming this is the statement, but that's not even clear either. So bad writing, but I think the point that learning, the point that you can never be too rich or too thin. You can never have too much DevOps or data science, data engineering skills is valid. So let's continue, and hopefully we'll get some sense of what those skills are. All right, so small data. Toolkits are an exciting concept. If you call a plumber to your house, they arrive with tools that help them be more effective than you could be at a task. If you hire a carpenter to build something at your house, they also have a unique set of tools that help them perform a task in a fraction of the time you could. Tools are essential to professionals, and DevOps, I thought we were talking about data engineering, is no exception. In this section, the tools of data engineering outline themselves. These tools include small data tasks like reading and writing files, using Pickle, using JSON, and reading and writing YAML files. See, this is the kind of stuff that... this is why I stopped reading this book. They write 10 chapters of making these analogies about like a plumber coming to your house to fix your toilet, and then it's all just for like a code example that's like import json.loads. Like, it's like 2 lines of code that like, it's like, I don't need to know that plumbers like come to your house and use tools to help them perform a task in a fraction of the time that you could if you didn't hire a plumber. First of all, I already know that. That's not insightful at all. Second of all, it's not a useful analogy to anything you're talking about. And third of all, just show me the code and explain why the code matters. Like pickling is for compression, right? But they're not even gonna tell you that. Using JSON and reading and writing YAML files. So like instead of talking about a plumber coming to your house to fix your toilet, tell me the difference between Pickle, JSON, and YAML. Being able to master sorry, I'm getting really upset. I stopped reading this book for a reason. Being able to master those formats is critical to be the type of automator who can tackle any task and turn it into a script. Tools for big data tasks are also covered later in the chapter. It discusses distinctly different tools than the tools used for small data. Why can't you just tell me what those are? Just like give me a Okay, I'm going to do a little bit of a... So, okay. I'm going to go to ChatGPT. Create for me a list of tools used in data engineering for small data purposes. Briefly include a description of which each tool does and a sample real world case where it would be used.
Data engineering, even for small-scale data purposes, involves a variety of tools that can manage, process, and analyze data efficiently. Here's a list of some common tools along with their descriptions and example use cases. 1. SQLite description, lightweight disk-based database that doesn't require a separate server process. SQLite supports standard SQL syntax and is accessible through various programming languages. Use case, a mobile app developer uses SQLite for storing user preferences and app state locally on a device. This allows for quick data retrieval and storage without needing an internet connection. 2. Pandas description, a Python library providing high-performance, easy-to-use data structures and data analysis tools. It is particularly well suited for tabular data. Use case, the data analyst uses Pandas to clean, transform, and analyze sales data from a small online store, preparing reports on monthly sales trends and customer behavior. 3. Apache Airflow description, an open-source platform to programmatically author, schedule, and monitor workflows. Airflow is used to manage the execution of data processing tasks on a predefined schedule. Use case, a small business uses Airflow to automate their daily...
Yeah, so anyway, I'm not going to go through all of these, but you can already see, this is the other frustrating thing, too, is like YAML, JSON, and Pickle aren't, like, that's not the thing. Like, we can see it. Like, Docker. Yes, you should be learning Docker. Jupyter Notebooks, definitely. They are great for, as we showed in the example, you can see the output in graphs and stuff. That's what matters. Excel is important. Pandas, SQLite, like YAML, and it's just, I feel like it's so overcomplicated a lot of the times. It's like, it's just a Python dictionary, but in a worse format. Except JSON, which is like not bad. Okay, so tools for big data tasks are also covered later in the chapter. It discusses distinctly different tools than the tools used for small data. What is big data and what is small data then? One easy way to figure out the distinction out, one easy way to figure the distinction out is the laptop test. Does it work on your laptop? If it doesn't, then it is big data. A good example is pandas. Pandas require between 5 to 10 times the amount of RAM as the dataset. If you have a 2 gigabyte file and you are using pandas, most likely your laptop won't work. Oh, I didn't know that. That's interesting. Dealing with let's see what the AI has to say about this. Evaluate this claim. This is my absolute favorite prompt. I do it all the time. I recommend everyone does this all the time.
The claim that pandas require between 5 to 10 times the amount of RAM as the dataset, and that loading a 2 gigabyte file using pandas would most likely render a laptop inoperable is a generalization that may not be accurate in all cases, but it does have basis in truth regarding how pandas handles data and memory. Understanding pandas and memory use of pandas is a Python library used for data manipulation and analysis, known for its ease of use, versatility, and efficiency with tabular data. One of the trade-offs for its high performance and flexibility, such as easy slicing, dicing, and aggregating of data, is its memory usage. When pandas reads a file into a data frame, it stores...
Alright, so it's, if you have a mega PC, then you'll be fine. So it's not, it's probably mostly true. Alright, so dealing with small data files. If there was a single defining trait of Python, it would be the relentless pursuit of efficiency in the language. A typical Python programmer wants to write just enough code to get a task done, but wants to stop at the point where the code becomes unreadable or terse. Also, a typical Python programmer will not want to write boilerplate code. This environment has led to a continuous evolution of useful patterns. One example of an active pattern is using the with statement to read and write files. The with statement handles the boring boilerplate parts of closing a file handle after the work has completed. The with statement is also used in other parts of the Python language to make tedious tasks less annoying. Write a file. This example shows that writing a file using the with statement automatically closes the file handle upon execution of a cold block. This syntax prevents bugs that can occur quickly when the handle is accidentally not closed. This is the thing that gets me too. We just spent the whole first part of this chapter talking about CEOs. Now we're learning something they teach in middle schools. Yes, this is how you do that in Python. Great. We learned that when we were very young. The output of the file reads like this. Yeah, okay, yes, thank you. I think that was addressed in the first chapter. Read a file. The with context also is the recommended way to read a file. Note that using read lines uses line breaks to return a lazily evaluated iterator. And then, of course, they throw in complicated language next to their simple examples because you're totally going to understand what that means if you don't know how to use with Python. Oh. All right, but what it means is it's an iterator, so you can loop through it. It's basically like a list, but it doesn't have different. It's something that you can iterate through. So like a string in Python is an iterator. If you do a help on a Python object, it'll tell you whether or not it's an iterator in the help. So in practice, this means you can handle large log files by using generator expressions and not worry about consuming all the memory on your machine. Yeah, so I'll demonstrate how to see if something's an iterator. So I can do temp equals test and then help on temp. It's a string, so you have to look at help like that. There we go. So this means it's a yeah. That means that you can loop through it. It's an iterator right there. So like something that you can't loop through. What can't you loop through in Python? I forget. So for letter in temp, print letter, but there's stuff you can't loop through. Oh, you know what? I don't think you can loop through a float. Okay, so here's a float. So if we do a type on temp, now it's a string because I have it in quotes. So I'm going to take it out of the quotes and do type again. Now it's a float. So let's get a help on it. Yep. Now we don't see the ITER dunder in there. So I can't loop through it anymore. So I'm going to say for number in temp, print number. It's not iterable. All right, so generator pipeline to read and process lines. This code is a generator function that opens a file and returns a generator, so yield, yeah. So def process file lazily uses generator to lazily process a file. So what a generator is it's a function that produces output that depends on how the function on when how many times the function has been called. So you're not going to always get back the same output that you would every time you run the function. A function always returns the same output if it is provided the same inputs. A generator, if you provide it the same inputs or no inputs at all, depending on how it's defined, can return different output each time it runs. So in this case, it will return, and a generator is a function, and it returns a generator object. So I'm actually going to do this one because I myself need to learn a bit more about generators. All right, so I've got Python 12 here, so we're going to do def process file lazily. Okay, and then with and I don't have a file to process. We'll do an import. We'll do a exit ls or dir. Let's see here. Well, let me do this. So I'm going to go back into Python. Now I'll do with open temp.txt for writing as f. I'm going to do f dot. We're going to say like for x in range 1000, like that. F dot write x. Oh. Oh. Why am I only getting the number 3? Oh, I got the number 1. Oh wait, I'm confused. Oh, you know what? It probably worked. So if I do a with, yeah, so I do a with open for reading now. Let me do f dot read. So do data equals f dot read. Print the data from the file. Oh, you know what? It's because I didn't. Yeah, but we can see it goes 0, 1, 2, 3, 4, 5, 6. Yeah, it's just I didn't add new lines. And then this is, I don't know what the numbers mean, but I think it was successful. So let me verify that. Yeah, so we can see it's successful now. I think the number is like a status code or something. I don't know. But now I can follow along. All right, so def process file lazily. And then we're going to do with open temp.txt as, I'm just going to call it F because I'm lazy too. Then we can do for line in f.readlines. We're going to do yield line. And because I'm using that yield statement, oh, you know what? I think my version of Python, you know what happened? I misspelled yield, it looks like. So there we go. There we go. And now I need to spell it correctly, which is Y-I-E. And there we go. So now, so next, this generator is used to create a pipeline to perform operations line by line. In this example, the line converts to a lowercase string. Many other actions could be chained together here, and it would be very efficient because it is only using the memory necessary to process one line at a time. So let's try that. And I'll do something different than converting it, but so now they're going to create a generator object. So they're going to call the function and save that called function to an object. So we're going to call it pipeline. All right, one thing I want to do, so let's do a help on pipeline first. Okay, so we can see it's a generator object. And we can do yeah. There we go. So one thing I do want to do just for fun is process file lazily and just see what happens if I do this. Okay, so we can see it created another generator object, but since that generator object hasn't been saved anywhere, it just was created and then immediately dissipated. It doesn't exist. It doesn't exist anywhere else. So this here is the generator definition, and then this pipeline here is the generator object, and then this one that I did here doesn't. It wasn't saved anywhere, so it just kind of came and went. So now what they're going to do is lowercase, but what I'm going to do is times it by 10. So we're going to say by 10 equals line equals number times 10 for number in pipeline. All right, so now we're going to print, and we've got this next here, which is a built-in function or class. So let's get help on it. So next we'll return the next item from the iterator. So we have an iterator here. The iterator is named by 10. So let's get a help on that. And we can do a type on it. So it's a generator, which is an iterable object. So if we do a help on it, Now we can see, yep, here it is. It's an iterator. So since it's an iterable object, we can use that built-in function of next to iterate through and see each step of each iteration of the object. So let's do print next by 10. And now we've got the number 0, the number 1, 2, 3. Interesting. Oh, you know what? It's because they're strings. So the way Python handles strings is, so if I do ABC times 10, now it duplicates the string 10 times. So that's what's happening. It's duplicating the value 10 times, and the value is a string that consists of the character 8 and a new line character. So we can see it duplicates that. So it's because they're strings. It's working as it's working. I understand why it's working. Sometimes it's just a little counterintuitive how Python works, so it kind of tripped me up a little bit there. But now that I've got my Python cap on, yeah, this is exactly how it should work. This is the output of the pipeline. So in my case, we can see the output is each line is now duplicated 10 times because it's a string, including that new line character is also duplicated. In practice, this means that files that are effectively infinite, because they are so large, could still be processed if the code works in a way that exists when it finds a condition. For example, perhaps you need to find a customer ID across terabytes of log data. A generator pipeline could look for this customer ID and then exit the processing at the first occurrence. There you go. In the world of big data, this is no longer a theoretical problem. So hear that? If you have a generator, so you could do this in two ways. So let's say we want to find the number, we want to do this until we want to see if there's a certain number in here. Well, you can either check the whole thing, or you can go through, and then once you find it, stop checking. With a generator, you can not only go through and find it once you stop checking, but you can utilize your resources in a line by line way, and not handling the whole file at once. So it's almost, I guess you could kind of think of it as like a container versus a virtual machine. I feel like you kind of can. Let me ask ChatGPT about that. Okay, so I just learned and reviewed the concept of generators in Python. So when it comes to a generator in Python, one of the big advantages you get is that if you're searching through a large file and you search through it as a generator object, then you can stop the search as soon as you find what you're looking for in the line of the file. And then there's another advantage too, from what I understood. It's less taxing on your hardware to do it this way than to do it in other ways. So my question is, can this be thought of as similar to the concept of like a container versus a virtual machine? Would it be fair to say that you get similar advantages for using generators instead of whatever else as you do when you use containers instead of virtual machines?
Your analogy captures the essence of choosing more efficient computing resources for specific tasks, but it's important to clarify the details and context where these comparisons apply. Generators in Python and the use of containers versus virtual machines, VMs, both illustrate the principle of efficiency and resource optimization, but they operate in different domains with distinct mechanisms and purposes. Generators in Python, what they are. Generators are a way of creating iterators in Python that allow you to iterate over data without storing it all in memory at once. This is particularly useful when dealing with large data sets or streams of data. Advantages. Memory efficiency. Generators are lazy, meaning they generate items only as they are requested, which is more memory efficient than storing large data set in memory. Performance. By processing one item at a time and potentially stopping early, e.g., when a certain condition is met, you can save computational resources and time. Containers versus virtual machines. What they are. Containers and VMs are technologies used for isolating and deploying applications, but they do so in different ways. VMs simulate entire hardware systems, allowing you to run multiple operating systems on one physical machine. Containers, on the other hand, share the host system kernel and isolate the application's runtime environment. Advantages of containers. Resource efficiency. Containers are more lightweight than VMs because they share the host kernel, rather than emulating hardware, which reduces the overhead. Speed. Containers can start up almost instantly, which is faster than booting a VM. This makes them ideal for scalable applications and microservices. Comparing the concepts while the specifics differ, the underlying advantage of using generators in Python and containers in the context of VMs is somewhat analogous in terms of efficiency. Generators and containers both provide more efficient use of resources. Generators do so at the level of data processing by using memory more efficiently and potentially reducing computing time. Containers achieve efficiency at the level of application deployment by using system resources more effectively and reducing the overhead compared to VMs. Optimization for specific use cases. Both choices are about optimizing for specific use cases. Generators are optimal for processing data streams where you don't need all the data at once, while containers are optimal for deploying applications that need to be lightweight, portable, and scalable. In summary, while the two concepts operate in different domains, data processing versus application deployment, the analogy captures a shared principle of resource optimization and efficiency. Both generators in Python and the use of containers over VMs represent choices to make operations less taxing on hardware by reducing unnecessary consumption of resources.
All right, so there we go. Yeah, it's similar. Okay, so using YAML, which I hate YAML so much. All right, so YAML is becoming an emerging standard for DevOps related configuration files because it's so much better than JSON, and it's also better than Python dictionaries apparently. It is a human readable data serialization format that is a superset of JSON. Interesting. It stands for YAML Ain't Markup Language. You often see YAML in build systems such as AWS Code Pipeline Circle CI or PaaS offerings such as Google App Engine. There is a reason YAML is so often used. There is a need for configuration language that allows rapid iteration when interacting with highly automated systems. Both a non-programmer and a programmer can intuitively figure out how to edit these files. Here is an example of YAML. Oh, see, this is the thing. This is not an example of YAML. This is an example of a Python dictionary. Okay, yeah, but we're writing it out to a file. So the output written to disk looks like this. Okay, so that actually is not that bad. The takeaway is that it makes it trivial to serialize a Python data structure into a format that is easy to edit and iterate on. Reading this file back is just 2 lines of code. Yeah, read it back in. The output can then be pretty printed. I mean, it can with yeah, but this is remember, this is a Python dictionary, which I think is better than YAML. I also think JSON is better than YAML. And I think a Python dictionary is better than both JSON and YAML. All right, so big data. Data has been growing at a rate faster than the growth of computer processing power. To make things even more interesting, Moore's law, which states that the speed and capability of computers can be expected to double every 2 years, effectively ceased to apply around 2015, according to Dr. David Patterson at UC Berkeley. So I'm going to do the thing I like to do. We're going to copy Dr. David Patterson. We're going to go on to LinkedIn. We're going to paste in David Patterson's name without all the book information. And then we're going to follow Dr. David Patterson on LinkedIn. So Dr. David Patterson is not a chiropractor. He is he could be both maybe, but he is a computer scientist at UC Berkeley. Or he was at the time of this. Yeah, so here we go. So let's see if he's... Oh, I guess he doesn't... I guess he's not very active. I think this is probably him. Oh, you know what? I think this is him. That's just like a... Yeah, so here we can follow this account. Yep, this is definitely Dr. David Patterson. Yeah, so this is the person I want to be following. All right. Okay, so CPU speed is only increasing around 3% per a year now, which is a lot different than it'd be like, so it'd be 100% per year, 200% per year. I don't know. 3% isn't that much. New methods of dealing with big data are necessary. Some of the new methods include using ASIC-like GPUs, tensor processing units, TPUs, and as well as AI and data platforms provided by cloud vendors. On the chip level, this means that a GPU could be the ideal target for a complex IT process instead of a CPU. Often, this GPU is paired together with a system that can deliver a distributed storage mechanism that allows both distributed computing and distributed disk input-output. An excellent example of this is Apache Spark, Amazon SageMaker, or the Google AI platform. So that's an example of often this GPU is paired. So it's an example of a GPU paired together with a system that can deliver a distributed storage mechanism. So such as Apache Spark, Amazon SageMaker, or the Google AI platform. All of them can utilize ASICs, GPU, TPU, and more, plus distributed storage along with a management system. Another example that is more low level is Amazon Spot instance deep learning AMIs with Amazon Elastic File System EFS mount points. For a DevOps professional, this means a few things. First, it means that special care when delivering software to these systems makes sense. For example, does the target platform have the correct GPU drivers? Are you deploying via containers? Is the system going to use distributed GPU processing? Is the data mostly batch or is it streaming? Thinking about these questions up front can go a long way to ensuring the correct architecture. One problem with buzzwords like AI, big data, cloud, or data scientist is that they mean different things to different people. Take data scientist, for example. In one company, it could mean someone who generates business intelligence dashboards for the sales team, and in another company, it could mean someone who is developing self-driving car software. Big data has a similar context issue. It can mean many different things depending on whom you meet. Here is one definition to consider. Do you need different software packages to handle data on your laptop than in production? An excellent example of a small data tool is the Pandas package. According to the author of the Pandas package, it can take between 5 and 10 times the amount of RAM as the size of the file used. In practice, if your laptop has 16 gigabytes of RAM and you open a 2 gigabyte comma separated value CSV file, it now has a big data problem because your laptop may not have enough RAM, 20 gigabytes, to work with the file. Instead, you may need to rethink how to handle the problem. Perhaps you can open a sample of the data or truncate the data to get around the problem initially. Here is an example of this exact problem and a workaround. Let's say you are supporting data scientists that keep running into pandas out of memory errors because they are using files too large for pandas. One such example is the Open Food Facts dataset from Kaggle. When uncompressed, the dataset is over 1 gigabyte. This problem fits precisely into the sweet spot of where pandas could struggle to process it. Not for me, because I got 16 gigabytes. One thing you can do is use the Unix shuf command to create a shuffled sample. Cool. So time shuff -n. In a little under 2 seconds, the file can be cut down to a manageable size. This approach is preferable to simply using heads or tails because the samples are randomly selected. This problem is significant for a data science workflow. Also, you can inspect the lines of the file to see what you are dealing with first. Alright. Using wc-l. The source file is about 350,000 lines, so grabbing 100,000 shuffled lines is approximately a third of the data. This task can be confirmed by looking at the transformed file. It shows 272 megabytes, around 1/3 of the size of the original 1 gigabyte file. So, alright. So if we do du-h, we can see the size, which is smaller. This size is much more manageable by pandas, and this process could then be turned into an automation workflow. That's cool. That creates randomized sample files for big data sources. That's awesome. Wow, okay, that's really cool. This type of process is just one of many particular workflows that big data demands. Wow, okay, that's awesome. Another definition of big data is by McKinsey. Not sure who that is. Who defined big data in 2011 as data sets whose size is beyond the typical database software tools to capture, store, manage, and analyze. This definition is reasonable as well, with the slight modification that it isn't just database software tools, it is any tool that touches data. When a tool that works well on a laptop, such as Pandas, Python, MySQL, deep learning/machine learning, Bash, and more, fails to perform conventionally due to the size or velocity rate of change of the data, it is now a big data problem. Big data problems require specialized tools, and the next section dives into this requirement. So I think with that, let me advance the bookmark. That's the most important thing. All right, get rid of the old one. All right, and I have to be somewhere fairly soon. I have to prep for being there. So yeah, that's the end of the video. It looks like I got another bookmark here I can get rid of. So yep, stay tuned for the next one where we look at big data tools, components, and platforms.